Welcome again to the Hydrogen and Fuel Cells and Batteries Group Exhibit 2016. My name is Robin, and today I'm talking to Dr. Simon Bourne, CTO at ITM Power, and his topic is rapid response electrolysis for grid balancing. Dr. Bourne, thank you for joining us.
Hi.
Hello. Perfect, so we'll get right into it with the difficult questions.
Thanks.
Can you please tell us a bit about your company, ITM Power?
Sure. Well, ITM is an electrolyser company based in Sheffield in the UK. We're about 70 employees, and we design, manufacture, and supply electrolyser products. We're focused on two main markets. The first is hydrogen generation for clean fuel for vehicles, and the second is energy storage, where we're capturing excess renewable power and converting that into hydrogen, which we put into the natural gas network. The systems that we supply are in the range of around 200 kilowatts to several megawatts, and we're at the moment in quite an exciting growth phase. Our revenue has been growing on average by 65% a year over the last 4 years, and we currently have a pipeline of £20 million. And we are partway through deploying 6 refueling stations in London, so it's a really busy year for us.
That's fantastic. 6, that's a very big project. What do you think about the equipment, or what do you think is different about your equipment or better between yours and other companies?
Okay. Well, our equipment is fully containerized, fully integrated, so all of the systems, not just the electrolysis, all of the control, the thermal management, all of the electronics to interface with the electricity network are all included. And crucially, I think the system is modular, and it's been a challenge for us in the past to be able to provide a wide range of systems to customers without falling into a trap of designing a product each time. So we've worked really hard to come up with a modular platform that means we can populate our products with different numbers of modules and manage to get some manufacturing efficiency, and it helps us to deliver more projects per year. The other thing I think is rapid response, and it's something I know we're going to come on to talk more about, but our electrolyzers are able to respond in less than 1 second, and that's quite important because it opens up another revenue stream to an owner and operator of one of our electrolyzers. The product actually is on our stand just there, so if anybody wants to come and have a look afterwards, we've got a full one on the stand.
And I recommend it. It's fantastic and very, very self-contained and clean looking.
Yeah, well, I've been told it has to be very clean.
Fantastic. What are the challenges, if any, in deploying the technology?
Well, I think with a new technology, there's a certain amount of caution, which is reasonable. And we've had to go through a lot of technical due diligence to deploy our first pieces of equipment. And that's been quite a tough and rigorous process, but justifiably so. We've also gone through very detailed compliance work. So the first time you deploy equipment, you obviously have the CE marking process to go through, but you also have local permitting to get through, which is different in every country usually. And we've learned a few hard lessons, to be frank, on how you do that efficiently over the years. And now we enjoy a position where we've got a number of pieces of equipment operating in the field, which means people can look at real data, people can talk to existing customers of ours about our technology and our products and understand what their reliability is like, how we perform as a company. And that's made a real difference in terms of being able to generate new business. And the first large-scale electrolyzer that we deployed for grid balancing was actually in Frankfurt in Germany, and that's been operating for nearly 3 years now. So there's quite a lot of operational data available that is very important evidence for people making decisions about what technology they'd like to get involved with.
So we're a very tried and true technology. Now going back to your topic, rapid response electrolysis for grid balancing, what is the rapid response in relation to exactly?
Okay, so I guess backing up a little bit, one of the challenges that our electricity network has to deal with is that the demand for electricity varies throughout the day. And most countries have planted up with power generation assets that are able to follow that demand curve. So we've got used to controlling the supply side of energy and power. And as time's moved on, we're deploying more and more renewable power. And that's far more difficult to schedule. And so the mismatch between supply and demand has got more and more difficult to deal with. And so that's led to a need for a new type of energy storage that we've not really had a requirement for before. And what's happened is there's now a range of services that can be provided on the demand side. And that means really if there's excess renewable power, maybe at night when the wind's blowing really hard, but the demand for electricity is low, there's excess power that can't easily be utilized. And what currently happens is much of that renewable power is switched off and curtailed. And that's not a very, politically, that's not a very good thing to do. And it also attracts a lot of penalty payments. So what we're able to do is offer a service where electrolyzers are very good loads. They will take power out of the network. So if we're able to supply an ability to respond very quickly under the control of a utility company, then we can get some availability payments to try and pull that renewable power out of the network. And the UK is quite an interesting place for us to do this because we've got a reasonable amount of renewable power, but our interconnections with surrounding countries, because we're an island, is quite limited. And so the structure for demand side management is very well defined in the UK. And broadly speaking, the faster you can make your electrolyzer respond, the more money you can get in terms of a grid balancing payment. And the most lucrative payment schedule is called enhanced frequency response. And that requires the electrolyzer to look at the grid frequency, and if it rises, it needs to switch on very rapidly in less than 1 second, and if it falls, it needs to switch off in less than 1 second. And we've gone through a pre-qualification process with National Grid to demonstrate that our electrolyzers can perform that function. And what it means to it gets a little bit nerdy, but what we're trying to do is build into the electrolyzer systems the capacity to attract these payments so that that functionality can happen in the background, and an owner and operator of an electrolyzer might not even realize it's taking place. But what it means for them is that they get an additional revenue stream which effectively averages down their electricity cost, which means the hydrogen cost from one of our electrolyzers with that capability is lower than it would be from another electrolyzer that hasn't got that capability. And we've spent a long time trying to understand how you make an electrolyzer respond that quickly without accelerating degradation and making sure that the whole system remains very functional.
Great. Anything else? Please go ahead.
And that's really where we are now. We've got a system operating in Frankfurt that's been live in the demand side services market for nearly 3 years, and we're in the process of deploying a number of refueling stations that will be aggregated together as a large load that will be operating under the control of National Grid. So it's an exciting time.
It's very, very exciting, of course. What are your main markets? Or you have subsidiaries as well, I believe?
That's right. Yeah. Our focus has been on the UK, Germany, and California. And we have the PLC is based in the UK, but we have a subsidiary in Germany in Frankfurt, and we have a subsidiary in California. And Germany has been a great early adoption market for us. We've sold 2 large power-to-gas plants here, and In California, we're in the process of deploying 2 refueling stations, hopefully more to come. And the UK, as I mentioned earlier, we'll have an additional 6 refueling stations operational in and around London by the end of this year. And the UK, as I mentioned, is quite an attractive territory because of this grid balancing service that's very well developed there.
Great. So getting such high demand, how's ITM Power preparing for this on the cell side?
Yeah, well, it's an interesting challenge because in the early days, the demand for products is quite lumpy, and so there tends to be an uneven manufacturing schedule. And we made some quite difficult design choices early on to make sure that we designed a product that was able to be manufactured in volume without significant design changes. And that means avoiding processes like milling out metal plates. We've invested in injection molding, for example, which has taken a long time to get right and achieve the quality that we need. But now we've got a process that is low cost, and we can produce many, many units very rapidly. And that, at the moment, we don't need to pull the trigger on all of the manufacturing processes that we've built into our product because volumes are still relatively low. But I think one thing that might help stand us apart from others when demand continues to grow in the way that it is that we can very, very rapidly scale up. We've reorganized our manufacturing facility so that we can increase the volume of units we make a year. We've developed a process of building all of the systems as different assemblies, so when the container arrives in the factory, everything gets put in the box very, very quickly. So the quicker you can put the equipment into the box, the more units you can manufacture a year. And that has required some very intensive work that isn't necessarily obvious when you look at the product from the outside, but it all is built into that product so that we can ramp up production as quickly as we can.
Any day times money, right? Are there any questions from the audience that I can take? Okay, I'll just come down quickly. Let's start here. Sorry.
Hello, Eva Ravn Nielsen, DTU, Denmark. When your electrolyzer will help grid services and respond to needs of the grid, then you can't have your electrolyzer running on full load or nominal production. If you have a high investment cost when you buy your electrolyzer, can you afford, or can your customers afford not to run full load hydrogen production?
There's a couple of answers to that. I think that the first one is that there are many, many grid balancing services, and the one that I mentioned in the UK, enhanced frequency response, requires a positive and negative response. So if you have, for example, a 3 megawatt electrolyzer, you may choose to operate that at 1.5 megawatts, and that is a nice, efficient operating point. And you can have an availability payment of 1.5 megawatts turn up capacity and also 1.5 megawatts of turn down capacity. So you're actually getting 2 sets of payments while running your plant at a good operating point. The other thing is that the very rapid response services don't tend to require a sustained response for very long. So it may just be held for a few seconds. You may be running at 1.5 megawatts and go to 3 megawatts for maybe a minute, 2 minutes, and then you're back down again. And so from a gas consumer point of view, you don't really notice. You don't notice that the electrolyzer is doing that. So that was the first point. I had a second point. I'm trying to remember what it is now. But I think making sure that you make the best use of the grid balancing services that are available to you is important, but also co-locating in certain circumstances works quite well. You can have a power-to-gas plant and a refueling plant together. Power-to-gas is quite useful because you can always operate the electrolyzer. You can always put gas into the natural gas network. Unlike a battery, for example, that you can charge up, but then you need to wait for a discharge event before you can charge it up again. The electrolyzer is a constant load. But if you have somebody who's interested in an electrolyzer to generate fuel for a refueling station, you're right. You need to make sure that you make an optimal operational decision about the plant.
Okay, thank you, Dr. Bourne. I have one more question back here.
Hi, Dr. Martin. I'm Akid from PSE London. It sounds like you've got had a lot of success in productizing your technology and making it commercial. Are you still putting a lot of focus on the R&D side, or is that kind of halting?
Yeah, the development is focused very tightly on product improvement, and the product improvement is really cost reduction, longer life, and ease of manufacture. And we have spent a lot of time working on cost reduction. You need to be slightly careful because often there's a driver to get the lowest possible capex, and that's important, but you also need to consider operational efficiency. And when you look at the cost composition of your hydrogen, a certain amount of it is capex, but a lot of it is opex and your electricity consumption. And the primary mechanism to reduce capex is to make the system work harder. So it's a little bit like a car. At 50 miles an hour, you get good miles per gallon. But if you want to drive at 100 miles an hour, your efficiency is reduced. So you need to look through the eyes of the owner-operator to understand the best trade-off between capex and opex. And that's what we've tried to embody into that unit.
Thank you very much. And there's also, there was an award, I believe, that you were just awarded?
That's true, yeah. We were very proud to be nominated for the Hermes Award this year. So that meant that we participated in the opening ceremony, which meant we were rubbing shoulders with Barack Obama and Angela Merkel. And we were presented with an award last night in another hall, and we've got the certificate in pride of place on the stand.
Fantastic, congratulations.
Thank you.
Anything else? Anything that you would like to basically for everyone to remember before we finish here?
I think maybe just finish on, if anybody's interested in understanding more detail, more than welcome to come to our stand. It's just there. You can look at the product and you can ask. There's about 10 of us on the stand, so we should be able to answer just about any technical question.
Thank you. So that is booth B66, and it's this one right here. They came in 2 weeks ago to bring their big container in, so it's beautiful. And so thank you so much for joining us today and for talking to us. And next we have Dr. Andreas Fommel from Fuel Cell Energy Solutions, GmbH. Thank you very much.
Thank you.